All right, everyone, buckle up because today we're diving headfirst into the world of software engineering.
Ooh, getting right to it, I see.
Well, our listeners, always eager to learn, and we got a ton to unpack, right?
Absolutely, especially with this Algocademy article, it's a goldmine.
No kidding. So for anyone out there dreaming of becoming a software engineer or, maybe already knee-deep in code and wanting that edge.
This one's for you.
100%. And you know what this article kept hammering home? It's not just about being a coding whiz.
It's about thinking the right way.
Yes. Algorithmic thinking, they call it. Sounds kind of intimidating, right?
It can, but honestly, this article does a great job of breaking it down.
Right. Because at first I was picturing like memorizing complex formulas and...
Oh, totally. Like some kind of mental gymnastics routine.
Exactly. But it's not like that at all, is it?
Not even close. It's more of a mindset shift. Like you can apply it to anything, not just code. Figuring out the fastest way to work, planning a dinner party.
Wait, so how is figuring out like the best route to work an algorithm? I'm intrigued.
Okay, think about it. You're considering traffic, maybe construction, back streets versus the highway.
Different options, weighing the pros and cons.
Exactly. You're unconsciously breaking down a complex problem into smaller steps, right? Choosing the most efficient path based on the available information. That's algorithmic thinking in action.
Whoa, okay, mind blown. I never thought of it like that.
Right. It's about finding those elegant solutions, the most efficient way to get from point A to point B, whether that's in your code or in your daily life.
Okay, I'm starting to see the connection.
Yeah.
But here's where I get a little tripped up. The article also mentions that simpler code is often better. So why bother with all this complex algorithmic thinking if you can just keep things straightforward?
The age-old debate. And it's a good question because, nobody wants code that looks like it was written in hieroglyphics.
Seriously.
But here's the thing. Sometimes, to achieve that true elegance, that simplicity on the user end, you need some clever thinking behind the scenes.
Okay. So give me an example. When does simple code just not cut it?
Let's say you're building an app, right? And it takes off, like explodes in popularity.
Okay, every developer's dream, right?
Right. But suddenly, you've got thousands, maybe millions of users, all that data. Simple code might not be able to handle that load. It could slow down, crash the whole 9 yards.
Oh, yeah, that's not good.
Not good at all. But if you've thought about this from the get-go, if you've used algorithmic thinking to build for scalability...
You're prepared.
Exactly. Your app can gracefully handle that growth. And that, my friend, is the power of thinking ahead, of anticipating those challenges.
Okay, I'm convinced. You've officially made me an algorithmic thinking believer.
Fantastic. Because it's not just about building something that works, it's about building something that lasts.
And that scales.
Yeah.
And that doesn't crash when a million people decide they need to use it at the same time.
Exactly. It's about thinking like an engineer, not just a coder.
And that's what sets you apart. Okay, so we've established that algorithmic thinking is, essential.
Essential.
But how do you actually get good at it? I mean, the article mentioned it can help you land a job at companies like Google.
Oh, yeah. Those interviews are infamous.
Right. And let's face it, those interviews are legendary for their tough algorithmic puzzles.
It's true. They want to see how you think, not just what you know.
So how do you even begin to prepare for that?
Well, the good news is anyone can develop these skills. It's like any other muscle. You've got to work it out.
So it's like hitting the mental gym.
Exactly. And lucky for us, the article's got some killer workout tips.
All right, hit me with those workout tips. I'm ready to get those algorithmic muscles bulging.
Okay, so the first thing is you got to practice consistently.
Makes sense. Rome wasn't built in a day, right?
Exactly. And luckily, we live in a time where there are resources galore. The article mentioned LeetCode. Ever heard of it?
Yeah, it's like a boot camp for your brain, right?
Yeah.
Tons of coding challenges.
Bingo. It's a fantastic way to flex those algorithmic thinking muscles. You're presented with a problem, and you've got to come up with the most efficient solution.
And I'm guessing there are multiple ways to solve these challenges, right? Not just one right answer.
Oh, absolutely. And that's where things get really interesting. Because it's not enough to just find a solution. You want to find the best solution.
Okay, so how do you measure what makes one solution better than another? I'm all ears.
Time and space complexity, my friend. Remember we talked about that earlier?
Yeah, it sounded important, but I'll be honest, still a little fuzzy on the details.
Okay, well, imagine you're searching for a specific book in a massive library, right? You could go through every single book one by one until you find it.
Talk about tedious.
Right. That's like a brute force approach in coding. It works, but it's not very efficient, especially as the size of the problem grows.
So what's the more elegant solution?
Think about how a library is organized. You've got the Dewey Decimal System, categories, subcategories. It's all about making information easily accessible.
So you can find the book you need without reading every single title on every single shelf.
Exactly. That's what we mean by time complexity, how the time it takes to execute your code scales as the amount of data increases.
So a good algorithm is like a well-organized library. It helps you find what you need quickly and efficiently.
You got it. And then there's space complexity. That's about how much memory your code uses. Going back to our library example, you could store information about every single book in a giant physical card catalog, right?
Taking up tons of space.
Tons. But what if you digitize that information? Suddenly, you can store and access a vast amount of data using far less physical space.
It's like the difference between carrying around a suitcase full of maps and having Google Maps on your phone. Same information, way less bulk.
Perfect analogy. And in programming, that translates to code that runs faster, smoother, and doesn't bring your computer to its knees.
So it's not just about getting the job done. It's about doing it in a way that's elegant, efficient, and scalable.
Exactly. And that's what sets apart the good programmers from the truly great ones.
This is making me think about something else I read, about the importance of learning from other people's code.
Oh, that's huge. Think of it like having a mentor look over your shoulder, right? You get to see how experienced programmers have tackled similar problems.
So it's not about copying their code. It's about understanding their thinking.
Yes.
Yeah.
You analyze their code, see how they structured their solutions, how they optimized for time and space complexity.
It's like a masterclass in algorithmic thinking.
Right. And, it's not just about acing those coding interviews. When you have this deeper understanding, it changes the way you approach every single project.
It's like you're not just writing code anymore, you're designing systems.
Exactly. You're thinking about the big picture, the long-term implications of your choices.
And that's got to be valuable in any coding job, right?
Absolutely. Because, let's be real, the tech world moves fast. New languages, new frameworks.
It's like trying to drink from a fire hose sometimes.
Tell me about it. But this is where that strong foundation in algorithmic thinking really pays off. You're not just learning a specific syntax, you're learning how to think.
So it's like you're not just learning to speak French, you're learning the grammar rules that underpin all languages.
Now you're getting it. You're able to adapt, to learn new things quickly because you understand the fundamental principles at play.
It's like having a master key that can unlock any door in the programming world.
And with that key, you can build anything. So you see, algorithmic thinking isn't just some abstract concept. It's the secret sauce that can take your coding skills to the next level.
I'm convinced. But let's bring this back to our listeners who are, maybe just starting their software engineering journey. How does all this translate into actual, tangible career success?
The million-dollar question. And luckily, we've got the answer. Well, for starters, imagine you're in a job interview.
Okay. Nerve-wracking, but go on.
And they throw a coding challenge your way.
The moment of truth.
Exactly. Now, anyone can try to memorize solutions, but when you've really honed those algorithmic thinking skills...
You see through the matrix?
Kind of. You're not just regurgitating code. You're breaking down the problem, explaining your thought process, talking about time and space complexity.
You're showing them you can think on your feet.
Yes. You're demonstrating that you're not just a code monkey. You're a problem solver, an innovator.
You're the Neo of coding.
Okay, maybe not Neo, but you get the idea. It's about showing them you have that extra something, that ability to not just code, but to think like an engineer.
And that is what gets you hired.
And promoted. Because think about it. When a complex project comes up, who are they going to turn to? The person who can simply code, or the one who can analyze the problem, design an elegant solution, explain it clearly to the team?
The algorithmic thinker.
It's a no-brainer.
Right. You become the go-to person, the one they trust with those mission-critical tasks. That's how you climb the ladder, my friend.
So it's not just about getting your foot in the door. It's about excelling once you're there. Exactly. It's about long-term success, about building a career that's both rewarding and future-proof.
Because let's face it, this field is constantly evolving.
Right.
What's hot today might be obsolete tomorrow.
It's true. But that's the beauty of algorithmic thinking. You're not learning a fixed set of skills that can become outdated. You're learning how to think, how to adapt.
So you can roll with the punches no matter what the tech world throws at you.
Exactly. You're not intimidated by new languages or frameworks because you understand the underlying principles, the fundamental concepts that drive it all.
It's like having a superpower. You can see through the noise and get to the heart of any problem.
I love that analogy. And, as we've been talking about all this, it makes you realize algorithmic thinking, it's not just for coding, is it?
Right. I was just thinking the same thing. It's like once you start seeing the world through this lens of breaking down problems, optimizing solutions.
It's everywhere. Planning a trip, organizing your kitchen, even choosing the fastest line at the grocery store.
It's all algorithms.
Exactly. And who knows, maybe by honing those coding skills, you'll actually find yourself approaching everyday challenges with more efficiency, more creativity.
Maybe we should all be coding. But seriously, this has been such an eye-opening conversation. We started talking about how to become a better programmer.
And ended up realizing we can apply these principles to our entire lives.
Absolutely. So to wrap things up, if you're even a little bit curious about the world of software engineering, do yourself a favor and check out this Algocademy article. It's a game changer.
100%. It'll make you think differently, that's for sure.
And who knows, it might just unlock a whole new way of seeing the world around you. That's all the time we have for today's deep dive, but keep those brains buzzing, and we'll catch you in the next one.